Let us start with Routing Information Protocol and open source shortest path first protocol. What is Routing Information Protocol? It is a dynamic routing protocol which uses hop count as a routing metric to find the best path between the source and the destination network. It is a distance vector routing protocol which has AD value 120 and works on the application layer of the OSI model. You might have a question, what is a hop count? Hop count is the number of routers occurring in between the source and the destination network. The path with the lowest hop count is considered as the best route to reach a network and therefore placed in the routing table. For example, if you want to go from Chennai to Delhi, now there are two paths available. Let us consider first you go to Bangalore, then to Pune, then to Gujarat and then to Delhi. The second path is you start from Chennai, go to Bangalore, go to Delhi. So these are the two paths. Which path you will choose? Obviously the shortest path or the path with minimum hop count. In the same way, RIP prevents routing loops by limiting the number of hops allowed in a path from source and destination. The maximum hop count allowed for RIP is 15 and hop count 16 is considered as network unreachable. What are the features of RIP? RIP updates of the network are exchanged periodically, then updates are always broadcasted, full routing tables are sent in updates, and routers always trust on routing information received from neighbor routers. This is also known as routing on rumors. So you might have guessed the disadvantage. Right, if one table entry is wrong, it will affect all the routers in that network. And that is why we prefer OSPF protocol, that is open source shortest path first protocol. Now let us see what is meant by OSPF. OSPF is another interior routing protocol. It is an intra-domain protocol and is based on the link state routing. For handling the routing efficiently and in a timely manner, the OSPF divides an autonomous system into different areas. What OSPF could do is the main question. OSPF provides solutions to most of the drawbacks of RIP. Using OSPF, we can scale up the routing architecture well beyond maximum 16 hops which were previously supported by RIP. Rather than exchanging node reachability, OSPF routers exchange link state information. Through the link state information, each router maintains a own copy of the network topology. From this link state database, it is possible to find the shortest routing path. Now for those of you who are familiar with the OSI routing scheme, many of the features supported by OSPF are similar to the OSI's routing protocol. The original versions of OSPF are actually derived from some of the earlier versions of the ISIS protocol. What are the features of OSPF? Type of service routing, which is mean it is possible to configure different routers to support different type of service requirements. The next is load balancing. When multiple routes are available, traffic can be evenly distributed over the routes. This would obviously result in a higher network efficiency. The next is subdivision of autonomous systems. It is possible to further divide the system into logical areas. This would improve the management of large autonomous systems. The next is security. The data exchanges in OSPF are authenticated. So only those hosts intended for the routing network are included in OSPF routing path. The fifth one is the host. OSPF supports specific network and sub-network routing. And the last is that OSPF is an open specification. In the figure, you can see that OSPF has a backbone area, area 0, and the other areas are divided areas of an autonomous system. So we saw why do we need routing protocols. We saw what is RIP. We discussed the advantages and disadvantages of RIP. To overcome the disadvantages of RIP, we introduced OSPF and we also saw the features of OSPF.